All right, so we're now moving on to the next section of our statistics and probability unit, and that's our section 7B. And we're going to deal with experimental and theoretical probability. So our learning objective for today, what you need to know is you just need to know the difference between experimental and theoretical probability and also how to answer questions using them. So first, we're going to talk about them together, talk about the two different definitions, and then we're going to go into some examples of each. All right, so first, what is experimental probability? Well, experimental probability is the probability that is based on repeated trials of an experiment. So we're actually performing the experiment. So when we perform the experiment, we can keep track of how many times our favorable outcome or how many times the event occurred, and then we can figure out the probability based on our experiment. Our theoretical probability is when all possible outcomes are equally likely, so meaning that our experiment isn't biased. Then the theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. So you see, when we're doing experimental probability, we actually perform the experiment. And we perform it over and over and over again to see, well, what is the probability of this event? Or when we perform when we perform the experiment over and over and over, we can then say, okay, let's look at the results and we could talk about the probability of each event based on our experiment. Whereas theoretical probability, we're not actually performing any experiments. We're just saying, oh, well, all of these have equally likely outcomes. So what will be the odds of us doing this? So for instance, on this first one, if we're rolling a die, well, maybe we roll the die or dice, let's say 10 times. And then we look and see, okay, well, how many times does a 5 roll? Well, let's say the 5 only occurred one time. Well, based on our experimental probability, it's the number of events that the events occurred. Well, if we're looking at rolling a 5, and we said it only happened one time, well, then our event that occurred place in our numerator will be that one, the 5 one time. And then how many times did we perform this experiment? Well, we performed it 10 times. So we would then say that the probability of rolling that 5 based on our experiment was 1 out of 10. Whereas theoretical, we're not actually performing the experiment. We're saying, okay, what are we looking for? Well, we're looking for rolling a 5. Well, on a dice, how many times does that happen? It happens one time. So our number of our favorable outcomes will be 1 in this example. But now the difference is we're saying, okay, well, how many possible different outcomes do we have in general? And there are 6 different, because we can get a 1 through 6. So you see now our numerator is 1 out of 6. So our probability of rolling a 5 theoretically should be a 1 out of 6 because they all have equally likely chances and odds of happening. So when we're rolling a 5, it should be that it's just 1 out of 6. We're talking about theoretically. However, as we know, if we roll a dice over and over again, we're not guaranteed to get a 5 every 6 time we roll it. It should or could happen based on the odds, but we know that that's not necessarily what will happen. So the experimental probability is based on our experiment, what did happen, and the theoretical probability is, okay, what should happen based on the odds of each event. So the experiment we're actually performing, and that's why it's over a number of trials, whereas our theoretical, we just say the number of possible favorable outcomes that we want versus the number of total outcomes that we can have. So you see how we can look at this a little bit differently. When we're dealing with experimental probability, we actually perform the repeated trials over and over again versus theoretical of what should happen. And we're going to do something about this or something with this in class as well to show us how experimental probability can lead to or should lead to the theoretical probability the more and more that we do something or the more and more we perform the experiment. All right, so let's go ahead and move on to some examples now. All right, so for this example, it says finding an experimental probability. So we have to be able to identify, are we doing experimental or are we doing theoretical? So experimental probability means we're actually using the cases that happen in our experiment. So the bar graph shows the results of rolling a number cube 50 times. So this means that we rolled or did the experiment a total of 50 times. So in my denominator, I know it's going to be over 50 because that's the number of trials, meaning the number of times that we performed this experiment. And then it says, what is the experimental probability of rolling an odd number? So our probability, we would put this as odd in parentheses because we're naming our event. So the probability of rolling an odd, well, now we need to go ahead and calculate, well, what are how many times we roll an odd number? So our odd numbers are 1, 3, and 5. Well, this 1, we see it rolled 10 times, so then we know that we had 10 ones. Our 3, we see that we rolled it 8 times, so we know that we had 8 of those. And with this 5, you see it's halfway in between this, so that means that it was 11 times. So if we want to do odd, we would add all them together. So it's going to be 18 plus 11, which is 29. So that's how many times it happened, or how many times the event that we're looking for took place. So that means that the probability is 29 out of 50. And if we want to put this in percentages or decimals, we can go ahead and do 29 divided by 50, which then means the probability of the event of odd taking place will be 0.58 or 58%. And if you wanted to talk about this in words, we would say that it is slightly likely to take place, maybe you would say, because it is above that 50%. So you can maybe say it is slightly likely or a little bit more than 50-50 chance for it to take place. All right, so that's finding the experimental probability. We look and say, okay, we perform this experiment 50 times, so we know that's what's in our denominator, because the number of trials goes in our denominator. And then in our numerator, it's how many times did our event take place. So number of times event took place. All right, so that's what we're putting in our numerator. And we needed to then figure out, well, we had 10 ones, 8 threes, and 11 fives, which meant that we have a total of 29 odd numbers. All right, so let's go ahead and do our next example. All right, so a lot of times when we do our statistics and these events and all this and probability, we're doing it because we want to make a prediction about what will or could happen in the future. Now, obviously, when we talk about probability, unless it is a 0 or a 1 or 0% or 100% chance, just because the odds say it should happen doesn't mean it will. But we can use this to make predictions. So it says it rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? So when we look, this will be our total number of experiment days that we did. We had 12 different experiment days, so that would be our denominator. Our numerator, we're talking about if this trend in rainy days, so our numerator would be how many days it rained out of that. So our probability of rain based on our March data is 2 out of 12, or we would say the probability of rain is 1 out of 6. We would still reduce these fractions when we're dealing with that. So that is our experimental probability. It's 1 out of 6 that it's a chance that it will rain. And if this trend continues, what we would then say is, well, the probability of it raining on any given day is going to be 1 out of 6. Well, how many days are there in April? Well, there's 30 days in April. So we would then multiply them two together and say that based on this experiment, that it will rain 5 days. So 5 days it will rain in April. Now, obviously, this does not mean that it's a foolproof and it's 100% going to happen. It's just saying based on the probability of the experiment that we performed or looked at in March, that if this trend continues, since there's 30 days in April, we would expect that it would rain 5 days in April. So you see, we're using the probability of our event. Our experiment was looking at the last 12 days of March. It rained 2 days, so that was our favorable outcome. So we're saying based on our experiment, the probability of it raining was 1 out of 6. And then since there's 30 days in April, we can multiply them together to say, well, if it follows this same pattern, that we would expect for it to rain 5 days in April. Right? Doesn't mean a guarantee will rain 5 days. It just means that if it follows this pattern based on the odds, this is what would or should or could happen. All right, now we're going to get into theoretical probability. All right, so now when we're doing theoretical probability, we're not actually performing an experiment. We're just saying theoretically what should happen or what could happen. Now, when we do an experiment, just because it's supposed to happen 1 every 5 times, it doesn't mean it will, but we're going to go over something in class to show you, well, what happens when we perform this experiment over and over and over and over. And essentially, if we can perform it an infinite amount of times, does that change? Will something occur to our probability? So something we are going to do in class. But for now, when we talk about theoretical probability, it's what should happen. And if we perform this experiment, this is what the odds of this event taking place. So what we're looked for is if you choose one of these letters at random, what is the theoretical probability of choosing a vowel? So the event we're looking for is a vowel. And when we are creating a probability, remember, we're looking, our numerator is our favorable outcomes. So we're saying, okay, what is it that we actually want to take place? What is it that we're looking for? In this case, it's choosing a vowel. And then on the bottom, it's just the total number of outcomes. Because theoretically, every single outcome has an equal chance of happening. So we don't have to worry about taking things into consideration. And theoretically, they all can occur equally likely. So when we're looking for a vowel, we need to first say, well, how many vowels do we have? Well, we have 1, we have 2, and we have 3. So we have 3 vowels. So when I'm looking for the probability of a vowel, my numerator is going to be 3. That's my favorable outcomes. Now the total number of outcomes, we have 3 vowels, so we have 4, 5, 6, and 7 total letters. So it becomes 3 out of 7. So if we're just talking theoretically, when I take a vowel out of this bag, if I put all these into a bag and pulled one, equally likely chance, I have a 3 out of 7 chance, or about a 43% chance of picking a vowel. Now, it doesn't mean that 100% I can't pick a vowel my first time, or that I'll never pick a vowel because it's less than 50. It just means that every single time that we go to do this, theoretically, we have a 43% chance, which is slightly less likely to happen. So if we were making a bet on this and saying, okay, do I think that this is going to happen? Then since it's slightly less, I would say, no, I'm going to say, let's go ahead and pick that it's going to be a consonant next. But it doesn't guarantee that it will be, because we're not actually performing the experiment in this case. We're saying this is what theoretically should happen based on the total number of letters I have and based on how many vowels there are, that I have a 43% chance of picking a vowel. Doesn't mean it's guaranteed to happen, but theoretically that's what should occur. And we're going to learn about this and talk about this in class, doing an experiment and then attaching it or taking that and discussing the theoretical aspect of it. All right. So this is what we're talking about. Theoretically, we're not performing the experiment. We're just saying what should happen based on the information that they all are equally likely to occur. All right. So for this one, we're now using theoretical probability to answer a question. So it says a theoretical probability of winning a bobblehead when spinning a prize is 1 out of 6. So we can say the probability of, let's just say, bobblehead, they told us is equal to 1 out of 6. And remember, this is our favorable outcomes over our total outcomes. And it says the wheel has 3 bobblehead sections. How many sections are on the wheel? So now we're trying to figure out, okay, how many total sections are on this wheel? So what we are doing then is we have this ratio of 1 over 6, and that is our ratio of favorable outcomes over total outcomes. So we've learned before that we can create proportions by using ratios and setting them equal. We just have to be consistent. So now I need to create a new, this is our theoretical. So this is what will happen on our very simplify all of our fractions all the way down as we can, because we're creating a ratio as well. We can think about it like that, but we're simplifying our events as much as we can. So it doesn't mean that there's only 6 spinning on this wheel or only 1 chance of winning. And as a matter of fact, we know it's not the case, because they tell us that there's 3 bobblehead sections. But remember, we need to be consistent. So I still need to do favorable over total. And since we're dealing with bobbleheads and they tell us that there are 3 sections in this spinning wheel that are bobbleheads, I know that that's representing my numerator because it's my favorable outcome. And then we're trying to figure out, well, how many total sections on there? Well, our 6 represent our total sections. We don't know. So that's our unknown, which we can say is x. Now we can use our cross multiply to solve, and we get 1 times x, which is x, 6 times 3, which is 18. So that means that there's 18 total sections on there. Because if there are 3 bobblehead sections, I know that 3 over 18 will reduce to 1 over 6, which is what we said our probability was in this example. So we can use these to predict the future as we did an experimental probability. We could still do that with theoretical as well, or we can use this information to then figure out some missing pieces. Like in this case, how many total sections were on that spinning wheel. All right, that is it for this video.